If you're a PC gamer, you've probably heard of the terms CPU bottlenecking and GPU bottlenecking. But do you really know what these terms mean and what exactly it entails? That's what I'm about to discuss in today's video. Hi, I'm Justin from Random Tech Videos, and I could go into the details of all the different kinds of system bottlenecks one can have. Want to make it clear, there's always going to be some kind of bottleneck, whether it's your CPU, your GPU, your RAM, your motherboard, your PCIe bus width, or even your power limit. But in today's video, I'm going to be discussing specifically the difference between CPU and GPU bottlenecking in a specific use case of gaming. Let's start with the symptoms of CPU bottlenecking. Now, of course, these symptoms I'm about to describe can be caused by other stuff, but this is typically a sign of CPU bottlenecking. With excessive CPU bottlenecking, one of the symptoms that frequently happens is micro stutter in games, and when random tasks execute, there can be larger hitches in the game that is being played. This can also cause random latency spikes. An example of an extreme CPU bottleneck would be trying to play a game like Battlefield 5 with an old Core i5 3550 paired with a RTX 4090 playing at 1080p. And extreme CPU bottlenecking and extreme GPU bottlenecking, you probably won't notice the difference between them necessarily on the impact in game. You might, depending on the game, but it's just not going to run right. When there's still bad bottlenecking but less than ultimately extreme, that's when you see the performance hitches and stutters that I talked about earlier. Now with GPU bottlenecking, typically you'll experience a more consistent but lower frame rate. Like instead of it playing at 60 FPS, you might get 30 or 15 or whatever. You might even get 2 FPS, but it'll still usually be consistent. GPU bottlenecking can also cause latency spikes and issues, but typically not to the extent of CPU bottlenecking. An extreme example of GPU bottlenecking would be trying to play Cyberpunk 2077 on a system that has an Intel i9 13900K paired with a GTX 1050. Okay, so basically to recap and state things in as simple terms as possible, CPU bottlenecking is when your CPU usage is at 100% and your GPU usage is not maxed out. And then GPU bottlenecking is when your GPU usage is at 100% and your CPU is not maxed out. Typically, you want to be GPU bottlenecked because you want your CPU to have some free room to run background tasks. And also with a GPU, if it's not at 100% usage, it means there's performance being left on the table. A lot of people are like, oh no, my GPU is at 100%. And they don't realize that's how it's supposed to run. The GPU is supposed to be the bottleneck. The bottlenecks that I was talking about earlier are if there's excessive bottlenecking. Now there might be a case sometimes where, let's say your CPU usage is at 30% and your GPU usage is at 60%. This would indicate that a bottleneck is not either the CPU or the GPU. The bottleneck in that case could be the game engine or something else being wrong with the system. Or it could just be that simply the frame rate in game has a limiter set. Okay, I'm gonna put this CPU versus GPU bottlenecking in even simpler terms using an analogy. Here you have two pipes. As you can see, one is obviously larger than the other. Let's pretend you have a GPU bottleneck. This is your CPU, this is your GPU. So now let's say our pipes are connected together. You pour water down this pipe, only a little is going to be able to come out this end. So that's a basic analogy of a GPU bottleneck. Now let's say it's your CPU. Well, just this is your CPU, this is your GPU. So this is your CPU. You can only put a little into your CPU. So your GPU is this huge pipe, but it's only having a stream trickling through it and not being fully utilized. Now this isn't the best analogy in the world, but it's one I could come up with in 5 minutes of brainstorming, so give me some slack. Back to what I mentioned earlier, there's no way to typically get rid of CPU bottlenecking or GPU bottlenecking altogether because GPU is typically going to be a bottleneck. No matter how powerful your system is, you want your GPU running at 100%. However, here's some tips to decrease the amount of bottlenecking in games. First, make sure your CPU and your GPU are matched properly. I gave examples earlier of mismatched CPUs and GPUs. But this video isn't about how to choose a good CPU for your GPU or GPU for your CPU. That's the topic for a whole nother video that I'm not even smart enough to get into. But just know that you want to have a good match between your CPU and your GPU to avoid excessive bottlenecking. It typically doesn't make sense to pair a high-end GPU with a low-end CPU or vice versa, with some exceptions of course. Now, if you do find yourself in a situation where your CPU is a bottleneck, you typically won't be able to get a higher frame rate, but your GPU will have plenty of headroom. So your GPU, if you give it more to process without taxing your CPU harder, you can at least get better visual fidelity even though you can't get a higher frame rate because your CPU is maxed out. So if your CPU is at 100% and your GPU is at like 20% and you're running at 1080p, well, you most likely can run it at 4K with no performance loss, and you can probably crank up some GPU intensive settings without losing too much performance. If your GPU is a bottleneck, well, it's usually pretty simple. Just turn some graphics settings down, lower the resolution you're rendering at, or even enable DLSS or FSR if available on the card you have and on the game you're running. I hope you found this video helpful. I know I probably got some of the stuff wrong. I did my best to research this. After all, I'm just a young guy who's enthusiastic about tech. I'm not pretending to be an expert. I'm just trying to help with what limited knowledge I have. I think I knew what I was talking about, but who knows, maybe I don't. If you found this video helpful, please consider giving it a like, and please consider subscribing to the channel. Anyway, until next time, thanks for watching and goodbye.